Decom. Sure, it's not referred. Hello and welcome to our today's class, and today we did our chemistry practical. Today's class is going to I wanted to share with me your experience. So please drop it in the comment section. Your experience through the practicals, both the physics and the chemistry practicals you guys had for Neco. And I believe that as you're having those practicals, you're taking notes because don't worry. I'm do something about it. I'll do something about it, you understand? Like, I want you to be comfortable as you walk. Okay, so like I was saying, before my network went out, like doing let me come closer so there. Doing Neco before waec is supposed to be an advantage to every student. waec is an exam that has global acceptance. Even if you're traveling to the UK, you're traveling to the United States of America, you're traveling to Canada, any of those states, you understand, they make use of waec. So the better your waec is, the better for you, understand. And since you're being given an advantage to write Neco before waec, it's like you're giving a mark. Like this, the deep mark, very deep mark, you understand? And it's strictly meant for you to be in tune to what is happening. So that once you write your exam, you're gonna dust it. Okay. So I'll use this wonderful opportunity to introduce to you guys our new past questions. We are publishing them. We have the e-copies. If you come to our website, educateafricans.com, this very website, you're gonna see the e-copy of these past questions, and we are the people doing it. So the quality is something else. Like the quality is out of this world, it's out of this planet. So you're gonna see it here. At some point, we are putting it up now. So you can buy them, we'll arrange them. We're gonna be selling copies of it. Yeah, you understand. If you need copy of any subject, you contact me. Contact me with my phone number. I'm gonna send you a copy that this is my phone number. I'll send you a copy that has me sign my autograph on it, thanking you for being my channel and product supporter. You understand? So we're gonna have physical copies of it. Once you pay, I send it through courier service. You get them. So you're gonna be seeing, apart from the past question, I'm gonna scribble some notes on the paper so that once it gets to you, you know it's coming from us. Exactly correct and original copies, you understand? So I want you to start getting our own past questions, you understand? It's deep quality the quality is something else. You have good explanations supporting the answers. When we give you an answer, we're gonna give you an explanation that will make you to understand that that answer that we gave you is really a correct one. So we are having plans around all these. You understand? We want to push out some good contents to you all over Nigeria, all over West Africa. You're in Ghana, you're in Gambia, you're doing West African examination, you're doing waec. You understand? We're trying to like push out these quality products. At some point, we're gonna push out our notes, the notes we use in making our lectures and everything. Push them out in different forms, so that they're going to get to you and you're going to make maximum use of it in trying to pass your exams. So as I said before, we have our past questions coming from us, Tclassified.com, Educate Africa, very different subjects and top notch. The past questions are done in a good way. After the question and the answer, you see supportive statements proving to you that the answer chosen is the right answer, and also trying to explain other things that are contextual to the very question that you're answering or you're attempting. So you can order for it if you need it. Like I said, we're also going to be having the physical copies like your normal book for each subject. Order for it, we'll send it to you anywhere you are. You're in Lagos, you're in Abuja, you're in Plateau, Port Harcourt, Enugu, Ibadan. We're going to send it across to you through courier service. You just pay, we'll send it. We have collections of past questions and some little notes. We're going to add up some little notes that will jot it down. So you get it and you use it for your stuff. So if you want to pay for it, and as you're buying our book, you're also supporting us. We're going to be selling a whole lot of things. Put some books together, put some other things together. We sell it across to our channel supporters and to our clients that are enjoying our work. So I want to put them together, put notes together, notes that are straight to the point of what you need for your exams. So those are the things we're going to be putting on in a short while, so that no matter where you are as a student, you'll be able to enjoy our products. Okay, so Chika, how was the chemistry practicals? Did you guys do was it titration that you did? Is it titration?
I've not yet done chemistry.
I can hear you very well. Like,
So I've not yet done chemistry. It's tomorrow.
that's true. Tomorrow, chemistry is tomorrow. That's true. That's true. Today is database. Is it database?
Data processing.
Huh? Data processing.
Yeah.
Is it practicals? Like you guys went to the lab and you had systems to where you practice data processing?
Yes.
Okay. So what kind of practical? What was it on? Like, what was the experience like?
MS, there was MS Word and there was Excel.
Come again. Come through again.
MS Access, MS Word, and Excel.
Wow.
I
MS
did.
Access. Then what?
They
Come
said,
again. I didn't get your last statement.
they said we should pick two from the three. So I picked Access and Word.
Wow. Incredible. Like, that's good, man. That's good. Like, I teach I teach computer operations where I teach people how to do Microsoft Word, Microsoft Excel spreadsheet, Microsoft Access, and a couple of other computer operation courses like graphics, Corel Draw, Microsoft PowerPoint. Uh, okay, so actually that's what they bring together and they call it data processing. Okay, interesting, interesting, interesting. Data processing. So you guys are going to be writing an exam on the same data processing.
Yes, sir. Sir, can you hear me?
Where to type out a some records to put inside the access, or some charts and graphs to build out formulas or stuffs inside the Excel. Was that what it was like?
Yes. Then they asked for cumulative score for some things and some other functions.
Come again. You're
So they
asked
had
to.
to do like, they asked them to do the cumulative score of some things. So they had to do like a bar chart of it, to find the maximum range and all that things, all those calculations.
No, I mean for you, not them, not them. For you that
Oh,
picked
okay.
MS Word and Access,
Oh,
what was it like?
Access, they just asked us to use our employer's ID. It's just basically the instructions that you should follow. It was really simple.
Instruction to key in records into the Access, was it?
Yes, that's all. So we just did like a table.
Like a table, then you key in the values, the records
Yes.
under different columns. The columns have headings, having the data under them, is it?
Yes, sir.
So what was it that you guys did on um
Word.
MS Word? MS Word, yeah,
They also
Microsoft
asked
Word.
for a table. They asked
You
for a
said
table. I said they also asked for a table.
table. Okay, how they
Just
trying
to
to
put
get
stuff
you guys'
in.
ability to insert table. Like they want to know whether
Yes,
you guys can insert table. Is it
yes, sir.
the table having specific number of columns and rows? Is it?
Yes, sir.
So were you asked to also put in some values into the table?
Yes, we were. They
Okay,
said we should pick our
it's
own
good.
values, like we put
So
put
like
our
I
own
can say
names.
that. Okay. Okay, so data processing is almost like basic computer operations. Interesting, like interesting. I never knew. It's so close and it's interesting. Okay, practical, good. So like in the lab, like you guys have a whole lot of computers there where people could sit down and get their stuff done.
Yes, sir.
Okay, interesting, interesting. It's good when younger people get to like mandatorily practice computer in school and now write it as part of your SSC. Did you put data processing in your waec, or like they are not doing such there?
So I put data processing my way.
Say,
Yes, I put data processing.
okay, interesting, interesting. Okay, so we're going to be looking at some aspects of biology, and because when you're doing biology practicals, you're going to find out that over time you're supposed to know the various classification of living things and be able to identify the diagrams of the various living things, especially those microorganisms like Euglena, Chlamydomonas, and the rest of them. So I want us to take a critical look at some organisms in preparation to our biology and okay, we are having chemistry tomorrow. You're supposed to deal more on chemistry. Like you're not supposed to like do other courses because I don't want to like be cloud our mind with other things apart from what we are seeing the next. Okay, leave biology until when we are getting closer to biology. Okay. Yeah. Chemistry is very important. So let me still get back to this. I think I should have done another example of titration. Yeah. Your courses. Yeah, so Chika, let's continue our discussion from yesterday. Like, are you having any gray areas in the solving in the way we laid out our calculations after conducting the basic wow, this is good, the basic titration?
No,
Were
sir.
there gray areas? Were there areas of concerns?
No, sir. I've not really gone through it because of my paper for tomorrow.
You said?
For today. I said, so I didn't really go through it because of yes. Today's paper.
Come again.
So from what you taught me yesterday, there was no problem. I've not really gone through it, so it will settle in my head well.
Okay, you were like preoccupied with your data processing that you were supposed to be writing today.
Yes, sir.
Nice one. That is good. It should be the right thing. Like it's always good to preoccupy your mind with the next thing you're writing. That is the best thing, so that some little things cannot just fly away like that when you're trying to capture another thing. So apparently, like you were okay with what you were doing because you are planning for your data processing, and today you've written your data processing. So like there are lots and lots of free spaces for you to now accumulate stuffs in practical chemistry, and that's why we're going to practical chemistry. I'm going to titration. I'm going to take a look at what we looked at yesterday and try to condense them in such a way that we can understand. So
They said that maybe after this titration, I think Neco said we should walk around ammonia carbonate salts.
okay, ammonium carbonate salts.
Yes. So,
Okay.
sir, please, maybe after the titration, you just tell me details I need to know about the salts.
Okay. Is it ammonium carbonate?
Yes, NH4, open bracket to CO3.
Yeah, ammonium carbonate. That's interesting. We're gonna look at that. Okay. So in titration, you just have this basic setup where you have your conical flux. Always know that conical flux is always where the reaction is taking place. And the very reaction taking place inside the conical flux is known as neutralization reaction. And it's basically whenever an acid reacts with a base in order to give out salt and water. So in the case of what we're going to be giving, we are having sodium hydrogen sulfate. So that looks like a salt. Some people are going to say, isn't this salt? We'll call it acid salt because all the hydrolyzable hydrogen ions did not go into reaction. You understand? So they are still left. This is what we call sodium hydrogen sulfate, sodium hydrogen tetrahydrogen sulfate 4. So this should be a salt, sodium sulfate, but it's still having hydrogen here. So we'll call it an acidic salt. So it's acting as an acid and reacting with this base, sodium hydroxide, in order to give us a pure salt, normal salt, sodium sulfate, and water. You can see that three of all these are aqueous, whereas the water is liquid. Interesting. So titration is whenever you're having a neutralization reaction that gives you salt and water. So it's always between an acid and a base. But take note, an acidic salt can also function as an acid in this neutralization reaction. And that is exactly what we're having here. Chika, are you there?
Yes, I'm here.
Okay, so after all this story, which is just the background to what we're going to be learning, then you're going to focus on the question that is being asked. Whenever you pick up your exam paper, you're going to see that A is a solution containing sodium hydrogen tetrasulfate 6. B is a solution containing 3.75 grams of sodium hydroxide being the base. That means that A stands for acid, B stands for base. Now put A into a burette and titrate against 20 cm or 25 cm of B. So what stays in the burette is the acid. So put the acid in the burette. You know, the burette is this longer one that you keep releasing as you're shaking your conical flask in order to have a proper reaction that is going to eventually change the color of the system. Okay, so now using methyl orange as an indicator, you know there are different types of indicator. But here we're going to be using methyl orange. Now record the values of A used. The values of A, like you know, A is the acid. Take note. A is the acid. Consistent value. So make sure you're getting a good value. But don't wait and say you are not getting the same 24, 24. Even if you get like 24, 23, 22, use it and do your calculation. Don't wait for a consistent value. Now get the average of the value of A used. So take note, this is capital layer A. It's telling you about the acid. Get the average of the acid. And I say if you're dividing two values, you divide by 2. If you're dividing three values, you divide by 3. Because it's got to be the average. Now determine the concentration of B, mole per dm cube. B is the base. Calculate the concentration, very easy. Mole per dm cube. So if you're given in gram, this is given in gram. So get the molar mass of these. 23 plus this, you get it together. Anything it gives you, then mole per dm cube is simply mass over molar mass. That gives you this. It's very simple. Calculate the concentration of A. Concentration of A is gotten using the formula CAVA all over CBVB equal to NaNB. Na over MB makes CA the subject of the formula, and you're going to find your CA. So you see, use the same formula that mole is equal to mass over molar mass. This you're not talking about A. And A is sodium hydrogen sulfate. Then finally you have 4, which is mass of the product. So you're gonna get the amount of these that went into reaction on these one. Then from the amount, get the moles. Then that mole is similar to this one because these are all in the ratio of 1:1:1. Then any mole that you get now try to get out the molar mass of these. So you have 23 plus 32 plus 16 times 4. So anything you get there, they multiply it by the molar mass of here, which should be 140 something. So that gives you the mass of sodium sulfate. Chika, did you understand the condensed version of what I just explained now?
Yes, I do.
Okay, so to open it up so that you see it much more clearer, you're going to state the equation of reaction, very important. Then you're going to state the volume of the pipette you're using. If you're using 25, you're going to write 25. If you're using 20, you're going to write 20. Some labs use 20, some 25. But in Nigeria, most of the labs there in Nigeria use 25. And you're going to state the indicator that you're going to be using, which is methyl orange. That is your indicator. And you're going to lay out your table exactly the way that I just laid it out. Some people have what we call rough before the first title, second title, and third title values. You understand? But if you just leave it like this, it doesn't really matter, provided you're taking your readings well. So you're gonna have final and initial. Initial is simply the first burette reading, which is always 0.00. Always do to two decimal places, If you have 5.4, it's gonna be 5.40. Now 0.1 is gonna be 0.10. So put it in two decimal places so that you're gonna have a consistent, accurate value. So very, very important. So I'm gonna go then more so that we see the procedure. This is the procedure of the reaction. So sucking it, so pour the acid into the burette until it gets to the 0 mark, because you want to take your initial reading at 0. Okay. Now suck the base, which is the B, into the pipette, and you know your pipette is 25. That's why we say that the volume of the base is already 25. But you don't know the volume of the acid, and that's why you're doing titration to determine the volume of the acid that can completely neutralize the base to get a sort of water. Okay, so that's the essence of the process. Now, note the yellowish color of the system. Once you add the methyl orange, you're going to observe that the color of the system, of the solution, or anything that is the liquid in your conical flask is changing towards yellow color. So that you know that once you are now adding the acid, you're going to determine the new color change. Very important, because your acid might be white in color, but once you add the indicator, you're going to notice a little color change. And that color change is not the color change you're looking for. The one you're looking for is the color change that happens when the acid is already reacting with the base. But you simply add that methyl orange to enable the visibility of that change in color for you to know when the reaction is at completion. Okay, now you start releasing the drops of the burette content, which is the acid, into the conical flask, while the color of the system changes to red, or this time, or to orange. Now, as you drop, you shake to enable color change. Now take the burette reading once color changes. So take the new reading, becomes the final reading once the color changes. Understand? This is this final change. Final reading here. So you repeat your this thing and start, or just start from where it stops. Now you know that when we read this one, as you're adding the acid, it got to this point. So this becomes the point before we start the next one. So the latter part, now you record the reading for 4.49. Now you refill again, that now the initial becomes 0.00. Conduct the experiment again, get this. So your tighter average volume of acid used is always the final minus the initial. The final is highlighted. It's not that initial. If the initial is highlighted, you know that the final is going to be even higher. So you take the subtractions and get this value. So these are the title values. So take the average. If you're picking only these two, it's going to be 22.4 plus 22.4 by 2, which is the 22.5. That is the value of the acid use, which is that's the volume of your acid use. So if you're checking out the first question, where you're told to calculate the molar, the concentration of B in mole per cube. First CAVA, CBVB, you're equal to NA by NB. Lay it out, make sure you put the right substitution. VA, the title value is always the volume of the acid, the volume of the acid. NA and N1 is simply this N and N, you get them from the equation, just the ratio. What's the ratio of the acid Na? It's 1. There's 1 here that you're not seeing. If it is 2, you see 2. And there's also 1 here that you're not seeing. So it's 1 over 1. So take note, that's how you get the Na over Nb. So lay out this formula very well. Ca is what you're looking for. Then make it the subject, put together every other thing. You're going to get your Ca at 0.105 mole by EMQ. So you've sorted out the second one. Now you look at the third one. Third one is asking about mass, and you know that molar concentration is equal to molar concentration is equal to mass over molar mass. So mass becomes molar concentration times molar mass. So this should be mass concentration. Like I said yesterday, it was a slip of hand. And I hope you do it, but you're still gonna get this as your mass concentration. Then the fourth one, you're told to calculate the amount. You're told to calculate the mass. So first of all, you get the amount, because amount equals to concentration times volume of 1,000. Concentration is you check it out for sodium hydroxide so that you can compare using the stoichiometry how it's going to affect the sodium sulfate that is formed as the salt. Okay, so having known the amounts, you now have to calculate the number of moles. Okay, mole is equal to amount, which is equal to times this. Okay, that's what we do here. So found the mole. So since this is the mole that is going into the reaction that gave equal amount of that in ratio, so this is also the mole that is coming out as your sodium sulfate. Okay,
and
to get the mass.
2SO4 acting as here in this equation.
Is it?
The Na2SO4, what is it acting as in this equation?
It is the salt of life. Because, why is it the salt? Because in every reaction between an acid and a base, neutralization reaction gives you salt and water. So you can see here, this is the salt, there's the water.
Okay.
So please make sure there's two here. I think there's a slip here. Chika, do you understand it?
Yes, sir.
Okay, so that's about it. That's about it for this
titration. Number 4 again. I want to see that number 4.
Yeah, look at it. Always take a look at this number 4 because that's where that's the only one that is a lot bit confusing. This molar mass that I found here is unnecessary. Like you could do that later. I think you would have started from here. Okay.
So use the concentration from the one in the base, right?
Yeah, concentration of the base. That's what I'm using because I'm comparing the base. Okay. That's the known solution. You know, base is a known solution. That's the most thing that you know so much. And that's why you're gonna use it. So you can start this very process here. This is where you would have started. This is where I would have started from here down. Then once I get to here, that's when I now do this molar mass, blah blah blah, and finally use this mass equal to mole times molar mass to sort out this 0.334, which is the final answer. Okay. Chika, are you there?
I understand it now. Yes, sir.
It's perfect now, ba?
Yes, sir.
Perfect. I love it when you understand it. So let's look at ammonium carbonate. Ammonium carbonate. Let's look at ammonium carbonate. Ammonium carbonate. Was that the salt you talked about? Was that the salt you talked about?
Yes, sir. That's the salt I talked about.
That's the salt we talked about. Salt. Let's get a briefing about this salt. The salt is looking interesting. You can see it's even got a Wikipedia like kind of page. So
I want to be sure when you react with NaOH, is it ammonia that you have as the gas or carbon dioxide you have as the gas?
How are the what? When you do what to it?
Like the gas, what gas will come out? Is it ammonia gas or carbon dioxide? I think it's
ammonia is likely. Yeah, ammonia is no. I don't think so. Okay, let's look at it. Let's look at this. Ammonium carbonate is a salt with the chemical formula this, since it readily degrades to ammonia and carbon upon heating. Okay, so you can actually get both of them upon heating, both the gas of the ammonia and the carbon dioxide upon heating, so you can get both gas. It is usually used as a leavening agent and also a smelling. Wow, interesting. This is a very interesting gas. Let's open it up. Let's open it up fully and let's look at it. Okay, ammonium carbonate is a salt with a chemical formula NH4 2CO3. Since it readily degrades to, because it readily degrades, it can always change easily to gaseous ammonia and carbon dioxide upon heating. Because of this, it is used as a leavening agent and as a smelling salt. It is also known as the baker's ammonia and was a predecessor to the more modern leavening agents, the baking soda and baking powder. It is a component of what was formerly known as sal volatile and salt of hot sun, and produces a pungent smell when baked. Okay. Production. Ammonium carbonate is produced by combining carbon dioxide and aqueous ammonia. About 8,000 tons per year we have produced ourselves. Okay, interesting. So it can also be called baker's ammonia. Take note. Now the composition. Ammonia carbonate slowly decomposes at standard temperature and pressure through two pathways. Thus, any initially pure sample of ammonium carbonate will soon become a mixture, including various byproducts. Wow, interesting. Ammonium carbonate can spontaneously decompose into ammonium bicarbonate and ammonia, with further decomposes to carbon dioxide, water, and another molecule of ammonia. So you see ammonia coming first as part of it when it decomposes before you have carbon dioxide. This is interesting. This is on Wikipedia. That's what we're checking out, Wikipedia. Chick, are you aware of Wikipedia?
Yes, I'm aware of it.
Yeah, they have a couple of information for you to digest whenever you're ready for it. Now, uses of ammonium carbonate is used as a leavening agent, leavening. Like something used for baking. That's what they call leavening agent. Unleavened bread, unleavened bread, unleavened. Okay, ammonium carbonate may be used as a leavening agent in traditional recipes, particularly those from Northern Europe and Scandinavia. Speculoos, Thumbra, and Lekuchen. I can't pronounce this. Sounds German. It was a precursor to today's more commonly used baking powder. When you say something is a precursor, like it was there before we started using baking powder. So it was used as a form of maybe baking powder before the normal baking powder that we're using now. Now, originally made from ground deer horn and called Hasson, today it is called baker's ammonia. It is prepared by the sublimation of a mixture of ammonium sulfate and calcium carbonate and occurs as a white powder or a hard white translucent mass. It acts as a heat activated leavening agent and breaks down into carbon dioxide, the leavening, and ammonia, which needs to dissipate. Okay, interesting. And water. It is sometimes combined with sodium bicarbonate to mimic as a double-acting baking powder and to help mask any ammonia smell not baked out. Interesting. Now, it also serves as an acidity regulator and has the E number E503. It's an acid regulator as well. Okay, it can be replaced with baking powder, but this may affect both the taste and texture of the finished product. Baker's ammonia should be used to create thin, dry baked goods like crackers and cookies. Crackers and cookies. Yeah, those are biscuits. This allows the strong ammonia smell to bake out. It should not be used to make most baked items like cake, since ammonia is hydrophilic and will leave a strong bitter taste. Okay, so mostly for crackers and cookies, things that are very dry. Okay, it's used as a leavening agent with associated controversy, which goes back to centuries. In the third kind of bread, a vascular appearance is given to it by blah blah blah. Other uses: ammonium carbonate is the main component of the smelling salts. Although the commercial scale of their production is small, Buckley's cough syrup from Canada today uses ammonium carbonate as an active ingredient intended to help relieve symptoms of bronchitis. It is also used as an emetic. It is also found in smokeless tobacco products such as Skull, and it is used in aqueous solution as a photographic lens cleaning agent, such as Eastman Kodak lens cleaner. It is also used for luring of apple maggots in Washington state to monitor the spread of infection and adjust the borders of apple maggot quarantine area. Interesting. Interesting. This chemical is an interesting chemical. So about the question you were asking about what would be liberated, I think that should be ammonia. Or what do you think,
Yes,
Chika?
sir, it's
What do you think?
ammonia.
Ammonia. Okay. So we're gonna be rounding up here, and I'm gonna be leaving you a whole lot of time to go also look at these very this equation that we have here. Let me remind you rightfully that from here down to here. um, okay, from here down to here might just come first before this one. Yeah, it doesn't really matter once you know where the direction where you're going. Chika, you good?
Yes,
Okay, so I'm gonna leave you time to go look at your chemistry again, and I hope you got the concepts that we were able to get out of this Wikipedia article. This article known as ammonium carbonate. Were you able to grab something from there?
yes, yes.
Yeah, the Pecas ammonia. Interesting, very interesting product or chemical baking. I never knew about this, like for real. Very interesting to me. Reading up this. It's nice to learn everything. Wow. So Chika, thank you.
You're welcome, sir.
Yeah. So please make sure you prepare very well for your titration. Like yeah, read a little bit, then rest. Make sure you rest very well. And once you enter the hall, focus and get everything done and done well. I'm wishing you good luck in your tomorrow paper. Thank you. God bless you. Yeah, you're through. Were you able to design it? Let me see it. Open it up. Open
Thank
it
you,
up.
sir.
Let me